Have you ever wondered why arrows have feathers at the back instead of the front? And what does it have to do with the fuel tank placement on NASA's new moon rocket? Stick around to find out. It really boils down to three things: center of gravity, center of pressure, and torque. Center of gravity is the average location of an object's weight. When an object is in free flight, any forces not in line with the center of gravity try to make it rotate about the center of gravity. An arrow is in free flight as soon as it stops touching the string of the bow. Now, finding the center of gravity for an arrow is really easy. You just find the point where it'll balance on your finger without falling. Now, center of pressure is the point on an object where we can imagine all of its aerodynamic forces to act. Aerodynamic forces are just the air forces that air exerts on an object, whether it's an arrow, a rocket, or a dog. Now, torque is a twisting force. It's trying to make an object rotate about a point. For a door, this point is the hinge, and the force is you pushing or pulling on the doorknob. For an arrow, the point of rotation is its center of gravity, and the force is just the aerodynamic forces. Now, torque is a force times a distance, so the greater the distance, the greater the torque. That's why doorknobs are placed far from the hinge. The greater distance gives you better torque when you're opening the door. So why do we have the feathers at the back? Well, we do it to shift the center of pressure rearwards, relative to the center of gravity. So when an object or when an arrow changes direction some, the aerodynamic forces acting at the center of pressure will create a torque in a direction that causes the arrow to rotate back towards its original direction. So what would happen if we put the feathers at the front instead of the back? Well, this would shift the center of pressure forwards ahead of the center of gravity. So let's go back to the arrow after it's deviated from its course a little bit. Now, the same aerodynamic forces acting at the new center of pressure will cause it a torque that will make it rotate even further, causing it to go even further off course, ruining its accuracy. So what does this have to do with the fuel tank placement in NASA's new moon rocket? Well, with an arrow, we get the center of pressure behind the center of gravity by adding feathers to the back. With a rocket, you don't want to be adding a bunch of feathers everywhere. Drag is the enemy. So instead, in order to keep the center of pressure behind the center of gravity, we shift the center of gravity higher. Now, the way we do this is by putting the liquid oxygen tank higher than the liquid hydrogen tank. See, the SLS runs on liquid hydrogen as its fuel and liquid oxygen as its oxidizer. Liquid oxygen is about 16 times as dense as liquid hydrogen, and the SLS carries about 6 times as much of it by weight. So by putting that much denser, heavier liquid oxygen higher than the liquid hydrogen, we are shifting the average weight upwards. That's the definition of center of gravity that we used earlier. So raising the center of gravity makes it so we can keep the center of pressure behind it. So whether it's an arrow or a rocket, having the center of pressure behind the center of gravity grants it inherent stability. Now check out a future video to see how bullets get to break this rule.